Hi team, welcome to session 21 Linux Logical Volume Management LVM. This is Linux Essential series. Let's start. What you will learn in this session: what is definition, what is LVM, what are the sequence of steps, how to create physical volume, then create logical volume, then create volume group, then logical volume, then make use of LVM, then physical volume management command, and then volume group commands, logical volume command, check the existing LVM, remove logical volume, and resize logical volumes. See, quite simple. If I have to explain the entire topic in one slide and here itself, a concept is something like this. If we have two disks of 1 GB each of these two disks are of 1 GB each, right? Let us see that. Okay, this is 1 GB and this also is of 1 GB. Now if I have a file of size 1.5 GB, I cannot store that file into these two disks because these two disks are separate disks. I have to split my file in order to save that. So is there any way that I can create a group of these two disks, treat them or make them as one single disk, and then store that 1.5 GB file onto these two disks of 1 GB each, putting together? It's kind of combining space of multiple disk or partition as one single disk or single partition is one line definition, and that whole concept is all about this. Advantages, disadvantages. Quite simply, I can talk now very easily. When I purchased my computer for the first time way back in 1991-92, I remember even 40 megabyte, 40 MB hard disk was very big size hard disk, very good size hard disk. And that 40 MB hard disk and the floppy disk of that size, that was a bottleneck, because when you keep on saving the files, your size of the disk exhausts. Then you have to buy a bigger system, bigger computer with a more hard disk, and then you copy the entire data into that. This term is called bottleneck because there's a one limited capacity. You cannot increase the capacity of the disk. And I continued that till very recently, around a few years back, where we have to add the disk and take a bigger disk. So point is, this concept of LVM remove that problem, because you keep on adding the disk and you don't have to copy the data. In case of such concept, what you do is you keep on adding disk and you keep on extending the logical volume. In your system also, if you remember, first partition was a primary partition /dev/sda1. That is the only partition. After that, the second partition, if you noticed, that was LVM created. By default, the second partition, then the default installation of RHEL7 is LVM. Second partition is converted into LVM. Why? Because you can add additional disk and you can extend that partition whenever you want. You can extend that space whenever you want by adding a partition to that. Because the concept of adding multiple disk, this is one disk, this is second disk. Let me draw it. And this is first disk, this is second disk, and now once the LVM is created out of these two disks, this is first part is this logical volume group, and then you can add another disk to it, and then you can extend this entire logical volume up to the third one. So the entire space is you keep on adding the disk, you can keep on extending the logical volume. That's the whole concept is this. So let's understand actually how it works and how to create it. Logical Volume Management LVM, also known as Logical Volume Manager, creates an abstraction layer between physical device such as disk and partitions and volumes that are formatted with a file system. For example, let's assume that the /home file system is configured on its own logical volume. If extra space is available on the volume group out of which it was created, then you can easily resize the file system. If no space is available, you can make room by adding new disk or partition and allocate the storage capacity of that disk to the volume group, and then extend the logical volume associated with it. We need to understand it in some diagrammatic way, and this is how it works. What you have is you create raw partitions, normal partitions. This is not one. Let's assume you have multiple partitions here, 3 partitions to be precise. Normal disk, F disk command, you created 3 partitions, or you have 3 disk, complete disk, full disk. Then the first step is you create physical volume. When you create physical volume out of those 3 partitions, mind it, these are 3 partitions. So the 3 partitions will be, initialized to be used in the logical volume group. So this initialization is converting this physical volumes, or initializing physical extent PEs. So this strips are representing the physical extent PEs. Then out of these PEs, or the physical volumes, once they are initialized, after initialization we create logical volumes. For example, out of the 3 disk or 3 partitions, we are creating 2 logical volume group of different sizes. And then out of these 2 logical volumes, we can create logical volume. This is logical volume group. You see that here. So out of this logical volume group, we can create logical volumes of 2 logical volume of the same size. So in other words, we had 3 partitions. They were initialized to physical volumes. They were converted to logical volume groups. We created a logical volume group out of them, and then we created logical volumes. And this is the actual usable space, and this is what is created when you install Linux for the first time. Also, your second partition is converted into a physical volume, then a volume group, and then a logical volume is created out of that. So the whole step, we need to do the entire steps, all the 4 steps, and in fact 3 steps we have to perform in order to understand the whole concept. So we'll be doing this in this presentation. So on LVM, volume groups are like storage pools, and they aggregate together the capacity of the multiple storage devices, which I mean partitions. Logical volumes reside on volume group. Logical volumes reside on volume groups. I'm talking about this. Logical volumes resides on volume group. This is volume group. There are 2 volume group created here, and can span multiple physical disks, because each of the logical volume group can be spread across multiple disks. For example, in this case we have 3 disks here, or 3 partitions here. So can span multiple physical disks or partitions. So this is how it works. This is the concept of logical volume. Outline of steps. First is, using fdisk, you need to create partitions with the partition ID of LVM, the way we have learned it in previous sessions, session number 19 to be precise. Once those partitions or disks are available, they need to be set as a physical volumes, PVs. That means this is the second step after partition is created. So this process, the second process, the partition, converting those partitions into PVs or physical volumes, will initialize the disk or partition for the use by LVM. This is what I told you, that initialization will happen. Then you create volume group out of 1 or more physical volumes after the initialization process is over. So the VG will organize the physical storage in the collection of disk chunks known as physical extents. And with the right command, then you can then organize these physical extents into the logical volumes. So this is the step. These are the outline of the step, broad steps, which we will perform in order to create our logical volume. Definition. Logical volumes are made of logical extents. Logical volume is made up of logical extents, means the last step. I'm talking about the last step. Logical volumes are made up of logical extents which map to the underlying physical extents, PEs. So we are going to talk about the L is logical extents or P is physical extents. Alright. You can then format the and mount the logical volumes. The definitions. Physical volume is the partition or the disk drive initialized to be used by LVM. And you know what is the meaning of this term, initialized? System ID. System ID is LVM. The way we initialized, we created in the session 19. Physical extent. The PE is the small uniform segment of the disk space, and PVs are split into PEs. Physical extent. Then volume group. A volume group is a storage pool made up of one or more PVs. That means once the PVs are created, then we initialize them, we convert them into the volume groups. We create a volume group out of them. Logical extents. Every PE is associated with an LE, logical extent, and these PEs can be combined into a logical volumes. Then we have finally the logical volume. Logical volume is a part of volume group as in made up of LE, logical extents. An LV can be formatted with a file system and then mounted on a directory of your choice. So essentially step number 1, convert your partition into the PE, physical extents, by using PV command. So PV command, then VG command, and then LV command. 3 broad steps. To create LV system, you need to create a PV, as I said, using PV create. So this is first command to be used on the partition, PV create. Assign the space from one or more PVs to VG. Second step, VG create. So we'll create VG after the PV creation is done. And finally we create LV. So 3 commands essentially are used to create the logical volume. First, PV create, which will be applied, which will be applicable for the partitions. Then VG create, which will be applicable on the PVs created in the step 1. Then we LV create, which is applicable on the second step, that is after VG create command. To add space to an existing logical volume, add free space from the existing VG with LV extend. We can extend the LVM, and that's the power, that's the whole purpose of this concept of LVM, that we can extend it whenever we need it. If you don't have any existing VG space, you need to add it by using unassigned PV with the command VG extend. So similarly, when we say LV extend, we have VG extend, and correspondingly we have PV extend also. So VG extend followed by LV extend. Of course, before that we have PV extend. So PV extend, VG extend, LV extend. This is how we extend that. If required, create a new PV from unassigned partition with PV create command. So first command is the PV create. To start with, we have to start with the PV create command. So first step, to start with a physical partition or a hard disk drive. Then set up PV by, such as for example dev SDC1, we use PV create on that partition, like PV create dev SDB1, and if you have multiple partitions you can use them separately. PV create SDB1, SDB2, SDB3. We'll create this PV create command after we learn the next command, VG create. So VG create, the VG volume group name, you have to specify the volume group name. VG create, the name of the VG which you want to keep, like this is the VG name, volume group name, out of the PV which we created in the previous step. These are the PVs, because after the PV command, PV create command is applied on a partition, it becomes the PV or physical volume. So VG create, and then if you want to add a third partition also, then we use VG extend. VG extend, the name of the PV or name of the VG, and then we use the partition. Let's see the demonstration of steps so far, whatever I covered so far. Let's see the demonstration of the commands. It is very interesting topic, my friends, and this very powerful, very interesting topic, and we cannot survive without it. It's a very important topic as well. So first step, fdisk /dev/sdb. I'm going to remove all the partitions, and I'll see only the those partitions are left, that is with marked with LVM. So I'm going to remove them. D partition number 3, D partition number 2, D partition number 1. So all partitions are deleted now. No partition is left. So quickly we'll set up new partition. Partition number primary partition number 1. All right. So default is, let's create partition of size 512 MB plus 512 M. Then again new partition, primary partition number 2, starting set, and then plus 502 512. This is my second partition. Not specified participant as KB. I have to remove it because I forgot to specify size. So partition number 2 I'm removing. Again creating new partitions. Primary partition number 2, default standard starting point, and plus 512 M. M was mandatory. Then again new partition, primary partition. I'm creating a partition number 3 of size 1024, start size, plus 1024 M. Partition is created. And now let's see the partition table. We have 3 partitions of size of type Linux only. We need to change them to the LVM type. So T is to change the system ID, and to see the partition number 3 or partition number 1, we need to change that partition system ID of partition 1. So 1, what is this 8E is the name of that code, or the system ID is 8E, if you remember that correctly, 8E. And let's print that and verify that yes, it is 8E. Again same command. I'm going to repeat the same command thrice. So partition number 2 8E, partition number 3, same command again, T command, partition number 3 and 8E again. And now I print it and I verify. Now you see all the 3 partitions are initialized as the system ID is changed to the Linux LVM. Now I can write it and come out of it. So first step is done. We have partitions which are initialized as LVM type. Partitions created, initialized as LVM type partitions, which is a 8 is the system ID. Then the first command was, if you remember, pv create /dev /sdb1 space /dev /sdb2. I'm going to use 2 partitions first, and then I will extend them. So third partition I will be using after I create the volume group, just to demonstrate. So pv create dev sdb1 sdb2. I've created that, so that's fine. Wipe it, yes. So we have successfully created the 2 physical volumes out of the 2 partitions. Now we create the volume group vg create tspvg. Let's say name of the vg is tspvg, and then /dev /sdb1 followed by /dev /sdb2. So we have successfully created the volume group out of the physical volumes, because 2 physical volumes were initialized, and we have created the volume group tspvg out of the physical volumes which we created. Now if you have to add the third partition also, step remains the same. First we create the physical volume out of the partition. So the pv create dev sdb3, that is the step number 1, and then we extend that vg extend. The command is vg extend extend vg extend the volume group name tspvg, and then partition or the physical volume which we just created, dev sdb3. So now successfully extended. So therefore what we have done in just 3 commands, we have created physical volumes First we used two partitions to create that. Then we created a volume group out of those partitions. We successfully created TSPVG out of that. Then we remember, oh, we have third partition also. Let's use that also. Assuming that there's a scenario that we have exhausted with the space. Assuming that there was the third partition was nothing but a new disk. So we added a new disk. We created a physical volume out of the disk or the partition. And then we extended our logical volume group, LVG group, volume group. So we have done the two commands, PV create, LV create. VG create, and we have also extended it now. Now we'll do the third command, which will be the next step. Let's do that. Let's understand first and then we'll do it. So I just demonstrated VG create out of the two, and then I extended it with the third one, TSP VG, and the third partition was added. And of course I first created the physical volume out of the partition by using PV create command. So now we have the third step left, last step. The new VG is not enough since we cannot format it or mount a file system on it. So we need to create the last step VG, that is called LVM, logical volume. So let's create logical volume out of that. So the command is lv create -l. This is how many extents you want to use. -l 256, and then tspvg. This is the volume group name which we have created earlier, and this is the logical volume name which we want to create. -n means name. tsp1, that is tsp1 means this is the logical volume tsp1. This will create the device with the name dev tspvg tsp1, and this device now can be formatted and can be mounted, and we can make a file system on it, and we use it to save files, to store files on it. This is the whole concept, right? So LVM, if you want to use the size, you can specify the size with uppercase M command. Let's learn that also. So if you use small l, then you have to specify the extents or the physical extents, right? That PEs. But if you want to use the size in megabyte or gigabyte, specify the size in conventional way, then you can use uppercase L. So LV create uppercase L. Like for example, I want to create a logical volume of size 750 MB, or because I have added all of them, so now I can use that. And let me show you this command now. Let's say the demonstration of this command. So the last command is lv create logical volume create -uppercase L, and the size is, let's say, 700 M. So 700 MB. I'm creating 700 MB size. From where? From TSPVG. And what is the name? I can specify, let's say, TSP1. So logical volume create, size 700 MB. TSPVG is the name of the volume group out of which I am creating, and then what is the name? TSP1. And now TSP1 volume is created. Now you see the information about of all these things whatever we have done. So first is PV display. It will display all the physical volumes which you have created out of three partitions. So that means you will see all the three partitions. Of course, this was the existing, as I said, when you install for the first time, this was the existing one, SDA2. This was created automatically at the time of installation. And this is one which we created, PV create, which we created just now, right? SDB1, PE size 4 MB, total PE 127. Alright, then we have physical volume, second one, SDB2. This is physical volume 2 which we created, and then third one we created, SDB3. So three physical volumes Now you can use VG display to display your volume group. So you have just created, the first one was the default, as I said, at the time of installation. So first one was the default at the time of installation. So I'm not talking about this because I have not created it. I created it at the time of installation. But this one is the one which I created just now, TSP VG. Then you can see LV display, logical volume display. You display the logical volumes which you just created. So as I said earlier, again same thing. This one is the first one which we created at the time of installation. This is the default created at the time of installation, and this one also created at the time of installation. But the one which I just created is this logical volume, and you know that dev TSPVG TSP1, and now I can make a file system on it. Let's say mkfs.xfs, and then I can specify the volume name dev TSPVG and TSP1. So this will make a file system on it, and my job is done, and now I can mount it and I use it. I can also use VGS PVS first to use the total as a summary of what all volume groups or physical volumes you have. These are the overall physical volume, just a list of all physical volume, PVS. Same way we have the command VGS, it will display volumes, a summary of the volume groups. Same way we have LVS, it will display only the logical volume. So if you just want to see the summary, we have PVS, we have VGS, and we have LVS, logical volume. Same way we have PV scan. If you just created a physical volume and you are getting error that it is not recognized or not available, then you can use PV scan. It will scan and it will verify and it will identify and display the scanned or the new physical volume. This command is required just in case you have created, you think you have done correct, but you are not able to see the physical volume. In that case you can use PV scan. Same way we have VG scan. You created VG and you are not able to see that, then you can scan your VG. Same way we have LV scan. So we have VG scan, PV scan, LV scan, PGS, VGS, LVS. Then we have VG extend. Similarly, we can now extend our logical volume also, LV extend. Let's take a look at the theoretical part of these commands now. There are more commands on the similar lines, exactly on the similar lines. Let's take a look. So this is the command which we have already used. PV create a physical volume. PV display the physical volume. PV move, actually move the PEs in a VG from specified PV to free location or another PV. So it is a prerequisite to disable PV, for example. So PV move will remove that or take it out of that. PV move. PV remove will remove the PV from the list of volumes. Means undo, or you created PV, now you want to undo that, you want to remove that PV. So PV remove can also be used. In the same way we have command for PV resize the PV, PVS I just showed you, and PV scan. So PV scan, PVS, I demonstrated these two commands. Then we have VG change, VG convert, VG create. So I just demonstrated VG create just now, and VG convert is basically from old style. If you have old version of LVM1, that means if you are using the old system, logical volume manager 1, and you want to convert that into volume 2 or LVM2 version 2, then you can use VG convert. And VG change allows you to change the configuration setting for VG. For example, you want to enable them or disable them, VG change. So then we have VG display, I demonstrated this command. VG extend, I demonstrated this command by extended that. Similarly, the way we are extended, we can reduce also, VG reduce, but then you are into a risk, you are taking a risk, because if there is a logical volume created out of it and you are using that, then it is your responsibility to make sure that it is not used. So it has to be taken, a great care has to be taken, needs to be taken if you are reducing the VG, because you need to ensure that there is no volume available and you are not using that. VG remove, same way you can remove the VG remove command. For example, if you use VG remove TSP VG, will remove the TSP VG, assuming that it has no LV. Please remember that there should be no LV assigned to it, no logical volume created out of it, and then only then you should remove it. VGS and VG scan, I demonstrated both these commands, VGS and VG scan. Same way, the third step, I demonstrated LV create, logical volume create, and I created this one. For example, LV create hyphen L 200 TSPVG1 from the volume group and the name of which we specify. Same way, LV display, I specify, I demonstrated. LV extend, we can extend that if you want to extend it. So LV remove, LV resize, LVS, LV scan. So these are the commands applicable for logical volumes, and I demonstrated this command as well, and this also. LV scan, resize and remove I have not demonstrated, extend I have not demonstrated, VG extend I demonstrated. So checking the existing, we have used VG scan. You can verify the configured volume group with VG display command, I demonstrated that. Although a number of LVM commands are available or installed, just 4 of them are active: LVM, LVM conf, LVM disk scan and LVM dump. Other LVM commands are obsolete and not implemented yet. The LVM command, if you simply start with LVM, it will drop you to LVM prompt, and there you can try the command LVM, for example, to start with help. So simply you can start with the help also to see what all available commands are there. Checking existing LVM, LVM conf can modify the default setting in the related configuration file, which is located here. This file, we normally don't get into that level that we go to this file and we make changes into this file. However, when I was working on the cloud, when I was configuring OpenStack Cloud, I had to go to this file and I had to set my filters that only filter these files or only filter these devices. So there are some good settings available in this. There's no harm in taking a look at this file if you want to learn more about the configurations and how LVM behaves on this command. LVM disk scan all available drives for LVM configured physical volumes. LVM dump sets your configuration report on root's home directory, so it will create a report of your LVM in your home directory as a root user. LVM dump. Remove a logical volume. The removal of existing LVM is done with LV remove. Like first you have to unmount the mounted logical volume and then you remove it, LV remove. The way we created it, we can simply remove it by that. Of course, as I said, it should not be in use. First you have to unmount it and then you remove it. So you should have LE from this, and this LE free, LV free for use in other LVs, right? So it will free all the logical extents. Extending or resizing logical volumes. Extend VG to include new partitions configured to the appropriate type. For example, we extended our own TSP VG, if you remember that. If you have another partition, let's say dev SDC1, and you want to extend that, you want to include that partition also. So similarly you can do VG extend, the name of the volume group and then name of the partition. Of course, I hope you remember that first you need to use pv create command on this partition to create physical volume out of the partition. Make sure the new partitions are included in the VG with the following command: VG display, and then you can use LV extend command. Simply this is how you can use the LV extend command. LV extend -L 200 MB and the size of the logical volume which you created earlier. Let's use the LV extend also, which I have not demonstrated till now. Let's use that also. So now LV extend hyphen L, and I want to extend it 300 MB slash dev slash whatever the name of the device slash dev slash tspvg slash tsp1. So this will extend our volume, not larger than the existing. Oh, it is not sufficient, so we don't have that much of size available because we have not extended our VG, we have not included our third volume in that. And let's try to add it, and I can try with 200 MB at least. Let me see if I can do that. No, larger. So we have only 175 extents available. Let's try with 20 MB. No, we don't have space available, so no problem. First what we will do is we will extend the volume group. Let's see, VG extend slash VG extend, and volume group is tspvg slash dev slash sdb3. That was the third partition, right? Slash VG extend tspvg slash dev slash sdb3 is already there. Okay, and then we should extend it. We should be able to extend that. Let me see what is missing, because if we have extended the volume group, then we can extend the logical volume as well. Let's try first LV display, and this is our TSP 700 MB. So total current LV 175, and let's see the volume group VG display, and here we have size of less than 1.99 GB VG size. So this is our volume group. So physical extents, total PE 509, allocated 175, free PE 330. That means we have 1.3 GB free, so we should be able to extend that. Let us try again. Oh, sorry, I missed that. Let me see that. Okay, so LV extend, one second. Okay, correct. So the point was I need to specify plus sign, plus 200 MB. So size, you have to specify plus sign, LV extend hyphen L plus 200 MB, TSPVG and TSP1. Now it is extended. See, I was missing the plus sign. So now it is extended, and now if you use LV display, now you will see it is 200 MB, 900 MB total. 700 we created earlier, plus 200 MB we just added now. Let's extend it more. Now I want to extend it more. Let's say I want to extend it another 200 MB, 256 MB, and now extended. See, successfully resized, and now you see now it is 1.13 GB. So now it is doing. So only thing was we were missing that plus sign. So we need to be careful about this. So we have extended our logical volume. So LV extend hyphen L. So we need to specify the currently up to this total So what is the meaning of this? If you don't specify plus sign, then what is the meaning of this? The meaning is whatever the size is, make it 200 MB. That was the problem. I'll show you what is the meaning of this. Again, I will demonstrate this because this plus without plus also will work, but then what is the meaning we need to understand. Let's do this also once again without plus sign. I'll explain the meaning of if you don't use plus sign, then what does it mean. I will just forgot, now I remember. So let's use the VG display first to see what is the status. VG display. So I have 1.99 GB of my volume group, nearly 2 GB of volume group, and the LV which I have is 1.13. So that means I can grow up to 1.7, 1700 safely. So now I will show you that command without plus sign. So that is how you specify. If you don't specify plus sign, then you specify to what extent you want to go. For example, I want to go to 1600 M. The meaning is I already have 1.13, that means 1100 something, 1130 I already have, and I want to take it to the size of 1600 MB. So what will be the actual size? Extension will be what? Around 500, around 470 something. So plus 1600 or plus 1800, meaning is it will take you to that. Maximum capacity will be 1800 MB. This is the meaning of without plus sign if you use that. And now it is done. And now the without plus sign will be the ultimate size. The maximum size will be that much. So you see now it is 1800. 0.4 MB. What do you see the difference? Difference is because of for the metadata. This is for the table size. Effective utilization will be 1.76 MB. So without plus, you have to specify the overall size. With plus sign means how much you want to extend over and above that. So this is the difference. That's what I missed, and I hope you have understood that now. So without plus sign is because of the total size, available size, and with plus you want to extend that. So can increase the space allocated in KB, MB or MB, even in terabyte. So like 2 GB and plus 2 GB, right? So if you prefer specify extra space, the plus sign is required for extra space to be added. Without plus sign, overall space. So without space, overall space, what space you want. Extra space means plus sign. Once you have extended the logical volume with LV extend command, and you have already had created the XFS file system on that, which I did, which I've created. You know, remember that I created mkfs command. Now you need to extend that with xfs _ grow fs command. Let's use that also on that, and let's see the size of the file system. That is an interesting point to take note of it, because that will complete our cycle, that creating partitions, creating physical volumes, creating volume groups, and then creating logical volumes out of that, and then using it. df-h. So they are not mounted. Df command will show only the mounted space. So since it is not mounted, so I cannot see that. Let me mount, then I will show you the size of that. Mount. Let me create a mount point first. mkdir / tsp volume and mount /dev /sda tsp vg /tsp1. I want to mount it on tsp volume at this place. I want to mount it here. Now if I use df-h command, now it will show you the size here. This is mounted, and look at the size. Size is 697 MB. This is the difference which I was talking about, because you made the file system before you extend the logical volume. So you see the size of the volume is before we extended the logical volume, and now I want to extend my XFS file system. So for that we have the command XFS underscore growfs, but first I need to unmount it. I first need to unmount it, unmount, and now I use XFS growfs, XFS underscore growfs, and now I extend it, dev tsp vg tsp1. Now it will extend it. Cannot find mount point for this, no such file or directory, cannot grow, is not mounted. Let's mount it if that is the case. It says we need to mount it. Let's mount it. Yes, done. Now if you use df command, you will see the size. Now you see the size of this 1.8 GB. So we have grown the size of the file system also. So the complete cycle is now complete. We created physical volume. First we created partitions, then we created physical volumes out of the partitions. We extend, then we create volume group, then we create logical volumes, then we extended volume group also, and we extended logical volumes also, and after that we also extended the file system created on the volume, logical volume, with XFS. And this is the last command which I demonstrated, extended this. That's all for this session. I hope you enjoyed it. Thank you very much for watching.